Hello my dear students, welcome to IMS Academy. I hope you are doing great. My dear students, the agenda of the foundation series is to have an idea on the topics on geotechnical. Geotechnical covers foundation and soil mechanics. Geotechnical and soil mechanics is a subject where we utilize the concepts of mechanics on the behavior of the soil. To understand the foundation design, we should know the basics of soil mechanics. As part of this, first we have studied about the properties of soil, and now we are going to classify the soil, like whether it is a fine-grained soil or whether it is a coarse-grained soil, on what basis you are going to classify the soil and what is the nature of the soil we will be trying to understand in this lecture. Before going to the session, my dear students, let me tell you one important thing. We at IMS Gate Academy offers 800 plus hours of gate coaching. It includes online gate coaching, offline gate coaching and self-recorded sessions. My dear students, we are providing a gate question booklet which covers 34 years of solutions. And my dear students, let me tell you one important thing here. We are providing the alternate solution, and at the same time we are providing you the key pointers for every question. Apart from this, we are giving you the QR code or recorded video for the difficult level questions. And we also provide subject-wise material, chapter, and we also give you exercise book which contains level 1, level 2, level 3 questions, which includes NAT, MSQ and MCQs. Apart from this, the key success for GATE students is, my dear students, let me tell you one important thing here. We are providing the mentorship session one-to-one, and also we are trying to provide you the most important things, that is, one second student. If you are trying to post anything, please let me know, okay? And we are also providing the chapter-wise test, advanced level test, multiple subject test, and we are providing 130 plus. The key success for students is we are providing one-to-one mentorship, and this will be creating a roadmap for the entire year. And also we are providing the doubt-solving portals. Now, my dear students, let us go quickly into the topic. So what is the today's topic is index properties. Let me tell you, we are going to discuss the topic name as index properties. Now see students, first of all, you should understand why do you want to study index properties. Now, index properties are useful for classification. Index properties are useful for classification and identification of the soil. Sir, classification can be, soil can be fine grained or coarse grained. So index properties are useful for what? These are useful for classifying the soil, and also these are useful for identification of the soil. So please understand why do you want to study about index properties of soil is, these are useful for classification and identification of the soil. And index properties also gives you rough estimation of engineering properties of the soil. What, sir? Index properties also give you rough estimation of engineering properties. It gives you rough estimation of engineering properties of soil. Now you can ask me here, what are engineering properties? Permeability, shear strength and compressibility. For now, you remember permeability means if there is a water tank and a pipe valve is there. If you open the valve, water will flow. If you close the valve, water will not flow. So permeability is a property in the soil which allows the passage of flow. If you talk about compressibility, my dear students, if you remove air from the voids, it is called compaction. If you remove water from voids, it is nothing but consolidation. If you remove both air and water, then it is called as compressibility. And we also talk about the shear strength, which will be responsible to understand the bearing capacity of the soil. So let us conclude, index properties are useful for classifying and identifying the soil. It also gives you rough estimation of the engineering properties of the soil. Now see students, here before going to the index properties, let me tell you one important thing. We have a concept called particle size distribution curve. What, sir? We have a concept called, let me 1 second show. 1 second. we have a concept called particle size distribution curve. Okay. Now let me draw the graph here, students. Now see, students, a graph is drawn between percentage finer and particle size. A graph is drawn between percentage finer and particle size. Okay. Now see, students, how these graphs will look like. Okay. Okay. Now see, students, a graph is drawn between percentage of finer. What do you mean by percentage finer? Means soil passing through 75 micron sieve. We call it as percentage finer. Now here, this we call it as well graded soil. And this we call it as poorly graded or gap graded soil. We call it as poorly graded or gap graded soil. And here we call it as this one as uniformly graded soil. This one we call it as what, sir? Uniformly graded soil. Okay, now my dear students, let me tell you what do you mean by well graded soil, what do you mean by poorly graded soil, what do you mean by uniformly graded soil. Now, if you take a soil sample, if all the particle sizes are present, then it is well graded soil. If you take some soil, if some particle sizes are missing, then we talk it as poorly or gap graded. What do you mean by uniformly graded? Means if you see here, all the particles are of same shape. Sorry, all the particles are of same size. So there are three kinds here you have to understand. One is well graded. If the particles of all sizes are present, then we call it as well graded. If some particle sizes are missing, then we call it as poorly or gap graded. If all the particles are of same size, then we call it as uniformly graded soil. So let us understand here, what do you mean by well graded soil? What do you mean by well graded soil? So here, my dear students, usually the shape recommended for well graded is S shape. What is the shape recommended for well graded? It is S shape. And in S shape, my dear students, if you call it as well graded, particles of, in well graded soil, particles of all sizes are, particles of all sizes are, particles of all sizes are present. Then it is known as well graded soil. And if you talk about uniformly graded, what will be the slope? Means what will be the shape? If you talk about the uniformly graded soil, it is a kind of steep slope. It is a kind of steep. Okay. And you can write here, all the particles are of, in uniformly graded soil, all the particles are of, all the particles are of same size. All the particles are of same size. Agree? Next we have is gap graded, or we can also call it as poorly graded soil. Now, in the name itself, gap or poorly graded means some particle sizes are missing. Okay, sir, what do you mean by gap graded or poorly graded? Means some particle sizes are some particle sizes are missing. So my dear students, I hope you are clear about the different shapes. If you talk about the poorly graded, the shape here will be hump shape. Okay, so these are the different kinds of particles based on the graph, how much soil is passing through the 75 micron and the particle size. And they can apply logarithm scale for that graph also. Now see students, we have another term called effective size. Sir, this is very important. Now when I talk about effective size is denoted as D10. Effective size is denoted as what, sir? D10. Now first of all, if anyone asks you what do you mean by effective size is, first remember my dear students, first of all you should remember that it is nothing but the size of sieve. If anyone asks you what do you mean by effective size means, first you should tell that it is a size of sieve where only 10% of the soil particles are passing. Where only 10% of soil particles are passing. Okay. Now here see my dear students, here we have D, right? This D represents the size of the sieve and 10 represents the percentage. So first of all, if anyone asks you what do you mean by effective size, it is nothing but the size of the sieve where only 10% of the soil particles are passing. I hope you are clear. Agree or not? Now coming to the most important one, that is coefficient of uniformity. Okay, sir. Next one we have is coefficient of uniformity. Now, what do you mean by coefficient of uniformity? And why do you study about this? Remember, see students, if you consider a soil sample, if you want to understand what is the size of the particle range, here by studying coefficient of uniformity, you will get an idea on the particle size range, from which size, smaller size to larger size. So the range of the soil particles, to get an idea on the range of the soil particles, you will study about the topic called coefficient of uniformity. And remember my dear students, coefficient of uniformity is given by the formula D60 upon D10. What, sir? Coefficient of uniformity is given by the formula D60 upon D10. Here you might ask me, see students, here you might ask me, sir, what do you mean by D60 here? Sir, D60 is nothing but the size of the sieve where 60% of the soil particles are passing. D10 is anyhow you know it is nothing but the effective size. So coefficient of uniformity discuss about the particle size range. Now my dear students, if you want to tell me here, see for uniformly graded soils, uniformly graded soils, coefficient of uniformity lies between 1 to 2. Okay. And remember my dear students, if the soil is well graded sand, Cu value should be greater than 6. And if the soil is said to be well graded gravel, Cu value should be more than 4. So my dear students, what is the advantage of learning a coefficient? Sir, if you learn about coefficient of friction, you want to know the surface condition. Similarly, we are knowing about the coefficient of uniformity to understand from which size to which size, like minimum size of the soil particle to the maximum size, or in simple words, we can have an idea on the particle size range. Coefficient of uniformity is defined as d60 upon d10, and remember, for uniformly graded soils Cu lies between 1 to 2, and for uniformly graded or you can say for well graded sand, Cu value should be greater than 6, and remember, for well graded gravel Cu value should be greater than 4. I hope this is clear for you regarding the coefficient of uniformity. Now we also have a topic called coefficient of curvature. Now my dear students, why do you want to study about the coefficient of curvature? Here see, the coefficient of curvature represents the shape of the curve. You have drawn the curve, no? You are telling a S shape, a hump shape and all. It gives you idea about it represents the shape of curve. So how will be the shape? Because something you might be studying in curve fitting. Similarly, coefficient of curvature will give you idea about the shape of the curve. Now coefficient of curvature is given by the formula d square 30 upon d60 into d10. d square 30 upon d60 into d10 is the formula for coefficient of curvature. Okay. So here my dear students, here also I would like to tell you, for well graded soil, when do you say that a soil is well graded? If all the particles are present. For a well graded soil, remember my dear students, the Cc value lies between 1 to 3. Here what sir? The Cc value lies between 1 to 3. So here please understand that what do you mean by coefficient of curvature? Coefficient of curvature will give you idea about the shape of the curve, and here Cc is nothing but d square 30 upon d60 into d10. For a well graded soil, Cc should lie between 1 to 3. I hope you are clear. Now see students, when you talk about actually how the soils are classified. Now see students, let me tell you how the soils are classified. We have to have an idea on this. See, soils are classified based on particle size. First, based on the particle size, my dear students, based on particle size, the soils have been classified. Okay. Now let me show you how they are classified. Okay. Now see students, here if you keep, I can say here up to 75 micron, and here I can put it as 2 micron. Okay. Now see student, below 2 micron we call it as clay. You can say here 2 micron, we can call it as clay. 75 micron, 2 micron to 75 micron, we can call it as silt, and up to 4.75 mm, you can call it as sand. Now see students, here we have again 0.425 mm, and also we have 2 mm. Okay, if it is between 0.42 mm, then it is fine sand. If it is between here, it is medium sand. And if it is between 2 mm to 4.75 mm, it is coarse sand. Are you getting, my dear students? See, less than 2 micron we can clay, 2 micron to 75 micron silt, 75 micron to 4.75 mm sand. And here if I talk about 80 mm, it is gravel. 80 to 300 mm, we call it as cobble, and more than 300 mm we can call it as boulders. So see students, here whatever I have classified here, All these things are classified based on particle size. To be more specific, my dear students, actually soils are classified into fine grain and coarse grain. In soil classification, okay, actually we will discuss those things also. Broadly, soils are classified into fine grain and coarse grain. And how they are classified here is based on the particle size. This is how they are classified. Now, my dear students, we have three organizations. Students, are you following, sir? If you are following, please let me know. Okay. Sorry, if you have any doubts, please let me know. Now, we have some organizations like PRA, HRB, and we also have IISc. Now, see students, all these are the organizations. What, sir? All these are the organizations. Now, see students, one is, you can say, Public Road Administration. What do you mean by PRA? We can write it as Public Road Administration. Okay, and another one we have is HRB. HRB is nothing but Highway Research Board. IISc. American Association, this is called as American Association. American Association. State Highways, American Association, State Highways. Transport officials. Can anyone tell me what is the beauty of these three things, sir? If you observe all the three bodies here, all three bodies are related to roads. Have you observed, sir? Highway Research Board, Public Road Administration, or American Association, State Highways Transport Officials. All these three bodies want to identify the soil which is best suitable for payments. Yes or no? Because they are related to the roads. So, all these three organizations want to identify the soil which is suitable for payments. Okay. Agree, students? Now, when I talk about the payments, what they have done is, they have given names like this: A1, A2, A3, so on up to A7. Now see students, they have classified the soil into 7 groups. What they have done, sir? They have classified the soil into how many groups? 7 groups. What they are trying to tell is, smaller the group, they want to tell that smaller the group, better is the soil for payment. What, sir? Smaller the group, better is the soil. Smaller the group, better is the soil for okay, better is. Now see, if you consider A1 or suppose A2 and A4, which is the best soil means A2 is the best soil, because they have told that smaller the group, better is the best soil. Now immediately, my dear students, you will ask me one doubt. If both are having same group, suppose if you have identified A3 and I also identified a group called A3, then which is the best group? Okay. Then comes a concept called group index. Okay, sir. Now see, sir, A7 soil is the means you cannot encourage this soil. Black cotton soils fall under this group. Why black cotton soils fall under A7 group? Or you can say this is the most unstable group for payments. Why black cotton soil will come under A7 group is, as you are already aware, black cotton soils have no swelling or shrinkage. Swelling is nothing but bulging, shrinkage is nothing but volume reduction. These are very weak in structure, Hence, they fall under A7 group. Now, if the groups are of, suppose if you have identified same group, to identify the best soil in the same group, they have come up with a concept called group index. What, sir? They have come up with a concept called group index. My dear students, if you like these concepts, please like and share our channel. Okay. Now, what do you mean by group index is, group index is used to identify the quality of the soil within the same group. What is the intention of group index? The intensity of group index is, it is wishing to identify the quality of the soil. Group index is used to indicate the quality of the soil within the same group. I can say within the, it is used to indicate the quality of the soil within the same group. Group index is used to indicate the quality of the soil within the same group. So here let me tell you one important thing, sir. Suppose if there are two soils, sir, like if there are A3 and A3, then which is the best soil? For that, to identify that, we are going with the group index. It is used to indicate the quality of the soil within the same group. So what they have done is, based on percentage of soil, based on percentage of soil passing through, based on the percentage of soil passing through 75 micron sieve, based on the percentage of soil passing through 75 micron, liquid limit and plastic limit. All these three are the parameters based on the soil passing through the 75 micron, liquid limit and plastic limit. I will be discussing these in detail in the tomorrow session when it comes to Atterberg limits. So based on these three parameters, group index has given a numbers 0 to 20. So you can say, my dear students, group index, GI means group index, varies between 0 to 20. Here also same funda, smaller the group index, better is the soil. So how do they indicate these numbers 0 to 20 is based on the amount, percentage of soil passing through the 75 micron sieve, liquid limit and plastic limit. Based on these three, definitely group index varies. Okay. Now see students, we have different kinds of soils. Now what are the different kinds of soils here we have is, first, how do you classify the soil? Okay, first we have is, my dear students, see there are different classification system. First let me tell you, airfield classification system. What, sir? Airfield classification system. There was a system called airfield classification system. On what basis they have classified is, on what basis they have classified the soil here is, you can say, first one is on the basis of particle size distribution, on the basis of particle size distribution. Okay. Next, compressibility, and plasticity characteristics. And what, sir? And plasticity character. So here let me tell you, see students, here on the basis of particle size distribution and compressibility, I told you removal of air and water is nothing but compressibility. Plasticity characteristics are nothing but liquid limit, plastic limit, shrinkage limit. Based on this, they have classified the soil into fine grained or coarse grained. And remember, my dear students, we have another system. We have another system called Unified Soil Classification System. Sorry, Airfield is also known as Unified Soil Classification System. And we also have Indian Standard Soil Classification System. Now remember, Indian Standard Soil Classification System is also derived from Unified Soil Classification System. So if Unified Soil Classification System is depending on particle size distribution and it also depends upon plasticity characteristics and compressibility. Similarly, Indian Standard Soil Classification System also depends on the same parameters. And remember, my dear students, Airfield Classification System is also known as Unified Soil Classification System, and it was discovered by Grades. Okay. Now coming to the Indian Standard Soil Classification System, let me tell you, we have two things. Okay. One is the fine grained soil. Other one we have is the coarse grained soil. Okay, let me tell you, we have two kinds of soils. One is fine grained and the other one we have is the coarse grained soil. So what do you mean by fine grained soil? If more than 50% of the soil is passing through, 75 micron sieve, if more than 50% is passing through 75 micron sieve, then we call it as fine grained soil. Similarly, if you talk about coarse grained, if more than 50% is retained on, 75 micron sieve. So here understand, students, or in simple words, coarse grain means more size, fine grain means less size. So what comes under fine grained particles, I will tell you. Here, my dear students, you can say clay and silt will come under fine grained particles, and here what comes under coarse grained, if you talk about, this is called coarse grained, and if you talk about coarse grained, here you will comes under gravel and sand. So students, if you are following the foundation series, it's my sincere advice, you can share and like the session. Okay. Okay, clear, students? Okay. Now see how we represent the soil. Here clay is represented as C, silt is represented as M, silt is represented as M, sand is represented as S, gravel is represented as G, and organic soils are represented by O. Actually, my dear students, almost soils are classified into 18 groups according to the Indian Standard Soil Classification System. Are you able to understand, students? According to Indian Standard Soil Classification System, soils are classified into how many groups? Soils are classified into 18 groups, you can write here. Soils are classified into according to the Indian Standard Soil Classification System, soils are classified into how many groups, sir? 18 groups. Now let me tell you one more thing, students. Here, if the liquid limit is less than or equal to 35, we call the soils as low compressible. Why I will tell you? Because to have an idea on plasticity chart, this is very important, students. Low compressibility. When liquid limit is less than or equal to 35, we call it as low compressibility. If the liquid limit is between 35 to 50, we call it as intermediate compressible. If the liquid limit is between 35 to 50, we call it as intermediate compressible. And remember, my dear students, if the liquid limit is more than 50, greater than or equal to 50, you can say highly compressible. Okay, based on the liquid limit, you have to tell whether it is low compressible, high compressible or intermediate compressible. Okay, now let us understand the most important topic, students, that is plasticity chart. We have a concept called plasticity chart. So for plasticity chart, let me draw the diagram here. Now see, students, if you see, this is called as a graph is drawn between plasticity index IP and liquid limit. Okay. Now my dear students, what do you mean by plasticity index here is IP is nothing but WL minus plastic limit. What is WL? Liquid limit. What is WP is nothing but plastic limit. So here this value is given as 20, okay, and if you see, now see, students, this is called, we call it as A line. Now see, this value is 35 and here we have is 50. Now above A line we call it as clay, CI, CH. Why else, sir? Less than 35, I told you low compressible, 35 to 50 intermediate compressible, more than 50 highly compressible. Now see, students, if the value is between 4 to 7, if the plasticity index is between 4 to 7, okay, here in this range, you will have the dual nature. It has both clay and silt. Here it is ML or OL. Here it is MI or OI. Here it is MH or OH. So what is this chart called is plasticity chart. Now what is the advantage here is you can classify whether it is a clayey soil or a silty soil, whether it is low compressible, intermediate compressible or highly compressible, you will get an idea. Now my dear students, if you see here the equation of A line here, the equation of A line is given. If you see here, what is the equation of A line here? The equation of A line here is nothing but IP is equal to 0.73 into WL minus 20. So here this we call it as equation of A line. Now see, students, this will help you, actually this will help you to solve the problems. Okay. For suppose, I will give you one example, students. The example here is, if they have given you liquid limit is 40 percentile and plastic limit is 20 percentile, they can ask you classify the soil. They can ask you classify the soil. I have given you simple question. Okay. Here whenever they have asked you these kind of things, first you should know IP for this solution will be very simple if you know the concept. IP value is nothing but WL minus WP. So here my dear students, if you see here, liquid limit is given as 40 and plastic limit is given as 20. So 40 minus plastic limit is 20. So this value will be equal to 20 percentile. Now you should have an idea on the A line. Okay, now please remember here students, equation of A line or locate IP. Equation of A line says IP is equal to 0.73 into liquid limit minus 20. So what is the given value of liquid limit in the question? It is 40 percentile. So if I substitute here, it will be 0.73 into 40 minus 20. So this will be equal to 14.66. Now how do we do is, now my dear students, A line is at a value of 14.66. Now how much value you have got? 20. So it is above A line. Now above A line means it is clay. It is evident that above A line means it is clearly from plasticity chart, above A line means it is clay. Now here what is the value of liquid limit? Liquid limit is between 35 to 50. When the value is between 35 to 50, we call it as intermediate. We call it as what, sir? So the answer here will be equal to CI. What is that CI? Above A line it is clay. And what is I means? I is nothing but the intermediate clay. So please write down the students. Okay, I hope you have written this. Students, I could not able to see the chart. If I could not respond, please let me know. Now my dear students, now see students, we have below A line, we can write below A line as what, sir? Below A line it can be silt, or you can say organic soils. Now to identify or to differentiate organic soils, we have different tests. Okay, we have different tests to determine the organic soil. Okay, so how do you distinguish the silt and the organic soils? Okay, now in that I'll write here tests to determine organic soils. What's the test to determine organic soils? Now the first one we have here is the color test. Color will be dark gray or brownish color. What's our color will be dark gray or brownish color. And how do you distinguish order is, you can say order will be bad order. Now the most important thing, let me tell you students, liquid limit after oven drying, liquid limit after oven drying reduces by, liquid limit or after oven drying reduces by more than 25%. Liquid limit after oven drying reduces by more than 25%. Then we treat that soil as, organic soil. Now let me tell you in a mathematical way this one. Suppose if the liquid limit is given as 80 percentile, I am just telling you for suppose or assume liquid limit as 80 percentile. Okay. For suppose if the liquid limit is given as 80 percentile, now after oven drying, if the liquid limit is reduces to 40 percentile. So how much reduction from 80 to 40 means? Reduction is 50 percentile. Sir, how do you check the reduction? Difference between those upon initial into 100. So it reduces more than 25%. That means it is an organic soil. That means it is an organic soil. Agree, my dear students? So how do you distinguish the organic soil, sir? First, color will be dark gray or brownish color. Order will be bad order. Liquid limit after oven drying reduces by more than 25%. Then we treat that soil as what, sir? Organic soil. Agree? Now see students, see we also have to see when you talk about fine grained soils, see students, what are the things which we discuss in fine grained soils? Okay. What are the concepts which are useful for fine grained soils are, we can say sedimentation analysis, and consistency limits are useful for consistency limits, or you can say Atterberg limits. Tomorrow I will be discussing only the Atterberg limits. Okay. Atterberg limits or consistency sedimentation analysis. These two methods are helpful for classifying the fine grained soils. Now coming to the coarse grained particles, see students, if I talk about the coarse grained particles, now what are useful for the classification of coarse grained is, you can say sieve analysis, and a relative density. Will be useful for classification of coarse grained soils. These two are important. In GATE 24, my dear students, there was a question came from relative density. Now, what do you mean by relative density? See, let me tell you, in GATE 24, they have given one question. What is relative density? It is useful for classification of coarse grained. Okay. Now, how do you define relative density? Relative density is also known as density index. Relative density is also known as what, sir? Density index. Here, my dear students, when I talk about density index, what do you mean by density index? ID, density index ID is equal to E max minus E by E max minus E minimum into 100. Okay, sir. ID is nothing but what? E max minus E by E max minus E minimum into 100. Now, when will be the void ratio maximum, sir? Void ratio will be maximum in case of loose state. Okay, void ratio will be minimum in case of dense state. And what is E? E is nothing but the void ratio in natural state. What happens in the GATE exam they have given here is, Sir, you know gamma D, if you talk about dry density is given by the formula gamma W into G upon 1 plus E. If you compare gamma W is constant, G is also constant. Based on this, gamma D is inversely proportional to void ratio. If the void ratio is more, gamma D will be minimum. So this formula can be written as density index is equal to 1 upon gamma D minimum in terms of gamma, because void ratio will be maximum, minus 1 by gamma D upon 1 by gamma D minimum minus 1 by gamma D max. So this is the relation which there was a GATE question asked in GATE 2024. Okay, here let us understand, my dear students. Now let us understand what we have discussed in the today's session. If you talk about the summary part, what we have discussed today. Now let me tell you what we have discussed today. Today, my dear students, we have come up with the well-graded soil. Well-graded. What do you mean by well-graded? Particles of all sizes are present. And usually well-graded will be in which shape, sir? S shape. And if you talk about poorly graded, some particles are missing. If you talk about poorly graded are nothing but what, my dear students? They are nothing but in the shape of hump. Okay. Similarly, if you talk about uniformly graded, in uniformly graded, all the particles are of same size, and here you can say it is in steep slope. Okay. So here these are the three things which are important in the soil classification. We have come up with the fact coefficients. Cu is equal to D60 by D10 and Cc, coefficient of curvature, is D square 30 upon D60 into D10. What do you mean by D10? It is nothing but the effective size, where only 10% of the soil particles are passing. And here, for any soil to be well graded, remember, my dear students, for any soil to be well graded, here you should understand clearly that for any soil to be well graded, you should understand clearly that it should satisfy both the conditions of Cu and Cc. Okay. Now, we also have studied about the equation of A line. Above A line, you can say clay, and below A line, you can say it is, equation of A line can be written as IP is equal to 0.73 into liquid limit minus 20 percentile. Okay. And remember, we have studied about the equation of A line. Similarly, I would like to tell you, we have studied that above A line it is what, sir? Clay, and below A line it is called silt or organic soils. And we have studied the most important formula, EDID, density index, is E max minus E by E max minus E minimum into 100. And E max is nothing but 1 upon gamma D minimum minus 1 upon gamma D upon 1 upon gamma D minimum minus 1 upon gamma D max. So, my dear students, it's my sincere request to all of you, if you have any queries, you can post in the chat box. And remember, my dear students, in the tomorrow's session, I'll be discussing the most interesting part, that is Atterberg limits or consistency limits. So what are Atterberg or consistency limit means? These are the water contents at which soil passes from one state to the other state. Okay. And remember, here we have liquid limit, plastic limit, shrinkage limit, and also we have the shrinkage ratio, volumetric shrinkage, plasticity index and all. So it will be a very interesting session in the next session. Now, before going to conclude the session, we at IMS GATE Academy offers 800 plus hours of GATE coaching. It includes online GATE coaching, self-recorded sessions, and also we will be doing the offline GATE coaching. We are the only institute who are providing the offline GATE coaching at Vijayawada near Bin Circle. We are excited to tell you we are also open another center in Bangalore near Malleshwaram. We have previously we used to have the center at Jayanagar, and we have added another session at Malleshwaram based on the student convenience. So what we do we are offering like subject wise material, and we also offer you exercise book which contains level 1, level 2, level 3 questions. Here it includes MSQs, MCQs and NITs. And remember my dear students, we are providing 130 plus tests to test yourself at every juncture. We are providing this. It includes chapter test, advanced test, multiple subject test and the All India mock test, which will be a replica of the GATE exam. And my dear students, the key success for the students at IMS GATE Academy is the one-to-one mentorship. Here in the entire journey for the roadmap for GATE 25, we will be discussing what are the strength and weakness and how that weakness can be converted into strength. We are also providing the doubt solving portal where the doubts can be resolved within 24 hours of time. And my dear students, if you have any queries, we at Jayanagar, we have Rahman, is the education advisor. You can come in contact with him or join the Telegram group below, given in the description below. Rahman is the right person who will explain you what are the opportunities through the GATE exam and what we do at IMS GATE Academy, how you can prepare the GATE preparation. I hope this video will create an impact on what are the index properties and how do you classify the soil. Thank you and all the best.